we were just super excited to have Max and David agree to do the panel discussion, but then we had a challenge because they could go at it for hours. So we needed a moderator who could actually reel them in and have a great debate. And so please welcome the editor of IEEE Spectrum, Eliza Strickland.
Hi, everybody. Thanks for the introduction. All right, so we're going to get a couple guys up here. I'm going to go through the introductions really quick because it's a lot more fun listening to those guys talk than it is listening to me talk. So we've got Max Tegmark, who is a physicist at MIT. His research focuses on precision cosmology. So he's using new measurements to better map the contours of the universe. He's also the scientific director at the Foundational Questions Institute, which is basically an organization that supports wacky ideas that could change our understanding of life, the universe, and everything. So he has fun there. He's also the author of Our Mathematical Universe, a recent book which came out in which he explores the ultimate nature of reality. In the course of writing that book, or probably just in the course of being Max, he spent a lot of time thinking about the ultimate nature of consciousness and came to the conclusion that consciousness is not some kind of magical pixie dust. It's more the way, he describes it as the way information feels as it's being processed in very particular ways by very particular molecules and very particular patterns. And if that's the case, then you can understand that consciousness is not necessarily limited to our fleshy bodies. So with no further ado, I'd like to bring up Max. Thank you. And we will also be joined by David Ferrucci, which is a great honor. He is the principal investigator behind IBM Watson, which I imagine most of you know about. Really the most impressive, dramatic feat of artificial intelligence I think most of us have ever seen. Watson used a combination of machine learning and natural language processing to trump the human competition on the game show Jeopardy! Actually, one of his opponents, Ken Jennings, wrote in his final Jeopardy answer, "I, for one, welcome our robotic overlords." So since then, Watson has gone on to healthcare. IBM now has some collaborations going on with the Mayo Clinic, Memorial Sloan Kettering Cancer Center, the New York Genome Center. And meanwhile, David has moved on to finance. He's now at Bridgewater Associates. He joined them in 2012. And there he is using artificial intelligence for macroeconomic modeling. So with no further ado, let's welcome David to the stage as well. Thank you. Great.
Hi.
Hello. All right, so we get going. I thought to get started, we could talk a little bit, since we're being hosted by Jonathan here, about artificial intelligence and its applications for healthcare. You've said that AI could enable a kind of rapid learning healthcare. And can you explain a little bit about what you mean by that and why AI could be, or why healthcare could be the kind of the killer app for AI?
Well, there's so many problems with healthcare. And it was already mentioned, incredibly expensive, huge amounts of information, changing rapidly. I mean, all the science is moving healthcare at an incredible rate, moving the knowledge that any doctor has to have access to, has to be able to reason over at an incredible rate. And it's a perfect application for AI systems that can acquire that data, can reason over that data, can deliver the insights from that data more effectively, more rapidly, and help overcome sort of the natural inferential biases that humans have. And thinking about the limitations humans have relative to computers, I think, is a really important driving motivation for the role of AI.
But you've also said that we can be sort of enamored with big data. We can begin to think that just because we can find correlations that we understand what's really happening. So is that a concern that we get stuck in correlation and we don't look for causality?
Yeah, I mean, I think there's two kinds of opportunities with AI. One is to learn from the patterns in the data, to discover things in the data, and I think there's a huge opportunity there. There's massive amounts of data out there. There are actually controlled experiments that have already been performed in the data, but no one even knows they're there. And you can get the machine to find them. And this is where the machine is looking for correlations and discovering them and popping them up. But then ultimately, to kind of make those really big discoveries, to make those inferential leaps, you have to do more than see those statistical correlations. You have to be able to map those correlations to some sort of causal model, to some deep understanding about what's the mechanisms going on, to some conceptual understanding that the doctors and the scientists can engage in and extend. And that's where that's a harder problem, actually. That's where you have to imbue the machine with not just the data, not just the numbers, but you have to imbue the machine with some sort of conceptual understanding of the problem so it can reason more mechanistically.
You have to understand the why.
Yeah.
And this is a question for both of you guys. Do you think that we need to model the human understanding of the why to have an AI that can understand it? How much should we be replicating our own processes here?
Well, that's a very interesting question. I think even if you can build an AI which will get answers to super difficult problems and get the correct answer, when we use such a machine, if some machine tells me that I should elect to do this risky procedure on my son because otherwise he's going to die or something, I would really like to know why, what reasoning went into this before I sign on the dotted line, right? So it's crucial that these machines are also able to explain to us. And how, as a teacher at MIT, do I explain things to my students? Well, by trying to understand how they think. Right? A machine has to be able to model the human mind quite well to be able to explain things to us. It's not good enough if it just has some sort of black box of doing things, unless it can also understand how we think about it and learn how to map its reasoning into terms we can understand.
And is that just then a question of trust? Does that have to be the case just so that we feel confident about employing these machines?
I think the human has to, and at some level, has to engage in that decision-making process. I mean, I was, literally exactly in that kind of situation where you just described, where my dad had gone into cardiac arrest, rushed to a hospital, and they wanted me to sign a DNR, do not resuscitate. And I asked them, well, what kind of evidence do you have? And they gave me that correlative evidence, basically statistical evidence, that 90% is, 90% chance he's brain dead. And I said, well, where's the actual deductive evidence? What is the data you have and what reasoning are you going through? And he refused to sign it. Long story short, 24 hours later, we were sitting up in bed with 0 brain damage. So this is the kind of thing where you do want the human to kind of, ultimately you're liable for these decisions. And while the statistics are powerful for helping you accelerate research, ultimately, what we desire is that conceptual understanding so we can follow that deductive path and say, oh, I actually know why I'm doing this. And that's a demand on artificial intelligence that has not yet been realized. So I think that's kind of what we face in AI, is the incredible power of the machine learning and the automatic or inductive reasoning. How do we marry that with the conceptual understanding?
And also just with the human interface, at what point does the human get to say, no, I'm not following that instruction?
Yeah, great question. Actually, where do we engage and at what level do we engage, and how do different experts at different levels engage at different points in that process?
And can you imagine this being applied to physics as well, these kind of questions?
Oh, absolutely, absolutely. I mean, there are clearly so many more things about our universe left to understand. We still have no clue what 95% of our universe is made out of, right? We were so proud when we figured out these roughly 100 atoms that make up us in this room. And then it turns out, well, oops, there's also this dark matter and this dark energy. We are also pretty excited that we've figured out that our universe is not 10, not 20, but 13.8 billion years old, but we have no clue what happened then and where it came from. So a lot of questions, obviously, AI will be able to should be able to help us answer more of them. I mean, every single thing that we love about our society and about our science comes from intelligence. So it goes without saying that having more of it gives us further opportunities. Even, I also feel, in a way, we're a little bit unfair towards AI, because whenever we keep defining artificial intelligence as that which we cannot yet do.
Right.
Yeah.
As soon as we get a machine to the complete chess, and that's not intelligent. As soon as you someone makes a machine that can win quiz shows, oh, that's not real intelligence.
Diagnose cancer, yeah.
Exactly.
Whatever.
But the fact is, like when we did this big 3-dimensional mapping of our universe that Jonathan was referring to, if you had to do all the math from that by hand, I could give it to a grad student and say, come back when you're done. It might take a billion years. By the time the answer is there, the universe would have changed a lot. So there's absolutely no doubt that we can go much farther with all areas of science, including physics and healthcare.
Well, I think the other thing that,
with AI.
that we were, Max and I were talking about this earlier. I mean, I think one of the other things that AI is it's almost an essential science in the sense that it's going to help us learn about ourselves. It's going to help us extend what we think it means to be human. We sit down and we so strongly identify with our intelligence. And as machines do more and more of that, it makes us step back and say, what does that mean about me? What are my values? If the machine is better at this and better at this and better at this, what does it mean to be human? And it pushes that question on us. It forces us to start thinking about what, a sense of who we are and what our evolving relationship with machines is going to be.
And you can imagine all these sort of task-specific AIs. You've got one for physics, you've got one for cancer. These programs are getting just fantastically good at what they do. But do you think there's a way that they can evolve to have a more generalized intelligence, something that we might indeed call consciousness?
You made a leap there.
Can we go from a narrow task-based? Let's leave consciousness out of it.
Yeah, for now. So, so I think yes. I mean, I think we can move to more general intelligences. I mean, I think when you look at how some of the deep learning stuff works, I mean, this is a very, very general mechanism that could be applied to lots and lots of domains.
Does it happen naturally, though? Does it just naturally, as you try and tackle bigger issues, is it naturally going to get more generally intelligent about the world?
Not today, not independently. So it can learn, but it's not going to do that independently. I mean, there's a huge amount of human involvement. I mean, humans are still interpreting the world for the algorithms. They're still coming and saying, these are the features to pay attention to. These are how the features are related. Now go compute the function or learn the function, if you will, given the training data. So, so the human is still interpreting the world in some sense for the machine. We haven't, anyway. So there's a leap there.
Yeah.
Yeah. I couldn't agree more with that. I think humans have again and again and again underestimated not only the size of our cosmos, realizing that everything we thought existed was just a small part of something grander, a planet, a solar system, a galaxy, a universe, and maybe other universes. But we've also just again and again and again underestimated the power of our human minds to understand our cosmos, and with this understanding, build better technology. And this is so insidious, it even infiltrates a lot of our common language. I mean, think about it. We say that there is a developing world and we are the developed world, which sort of implies that we're done with technology. We've arrived. This is it. This is as good as it gets. Similarly, right, there's just so much in human culture about how this particular kind of quark blob, that we have on our heads is the most intelligent thing that you can put quarks together to do.
What do you call a quark blob?
I'll take it as a compliment. But, for me as a physicist, this feels very arrogant to think that this is the coolest kind of, that it's impossible to arrange quarks in a way that they can process information even better. And particularly from the cosmology perspective that I have in my day job, we live in a universe that's 13.8 billion years old, right? And it's vast, we are young whippersnappers here who haven't been here as a species for that long in the cosmic perspective. Why should this be the most advanced information processing possible? So I completely agree that, there seems to be nothing in physics, no law of physics that says that the only way you can make an intelligent quark blob is by putting them together into carbon atoms and oxygen atoms and make them like mushy and
gray matter.
Yeah, and it's just that we haven't figured out another way of doing it yet. But we should not underestimate, our human ability to make other things.
But do we want to and do we need to? Is there a purpose in building a generally intelligent AI?
Yes and yes.
Okay, why? Why and why?
That's one person's perspective anyway. I mean, I think we want to because as our world gets more and more complex, we're creating literally, both our ambitions, desires, and the mess that we're making in terms of the huge amount of scientific knowledge we're creating and having difficulties sifting through and connecting and so forth. We need the help of the machines. I mean, I think one of the things I've seen happen even, in my years in AI is the attitudes toward it dramatically changing. There's much more of an awareness. Wow, we're just not perfect. Our brains, our cognition is severely limited. We make mistakes, we can't remember, and wow, machines are getting better. And there's just a willingness to accept and understand that. And I think fewer and fewer people are doubting the absolute requirement that we engage machines to reach our own ambitions and deal with the complexity that we ourselves are creating. So that's one. So I think we need to, and should we, I think we have no choice. And we have no choice for one, for the practical reason I just mentioned, but then for the philosophical reason, which you may or may not agree with, which is, this is the way we're going to develop a deeper understanding of who we are. We have to come to grips with what we were talking about before, that existential question. Who are we and why are we? What are we? And understanding intelligence is just critical for exploring that. And I'm the type who I don't want to put the blinders on. I want to deal with the reality.
You're gung-ho as well?
I also feel, as I was saying, that first of all, technology itself, I mean, I love technology. There's even the word technology in the name of the university where I work, right? Every single way in which 2014 is better than the Stone Age is because of technology. At the same time, of course, we have to remember technology is powerful. Whenever you invent something powerful, it opens up great possible benefits and new pitfalls, right? When fire was invented, that's a technology, had a lot of benefits. We use it a lot. But there were also some pitfalls. Gradually, people realized that we have to also do some research into how we can avoid them. And if you look over there, see, there's a fire exit, right? And similarly, we invented nuclear technology. Maybe that's what's powering these lights here. But obvious pitfalls, and it's worth thinking about how to avoid them. Biotech, same thing there. And AI, in my opinion, is the most powerful technology ever to be on the verge of being invented. It's going to transform society like nothing else. So, of course, in parallel with developing the capabilities of AI, it's important that we also think hard about these questions. What are the benefits? What are the pitfalls? And what can we do now? What constructive things can we do now to get these benefits while avoiding the pitfalls? In other words, we shouldn't just be dismissive of them and say there are no pitfalls. We should think, how can we avoid them?
And so you you signed an editorial, I believe, with Stephen Hawking and a few other luminaries. I want to read one quote from that editorial. It was a great line. It says, "If a superior alien civilization sent us a message saying, 'We'll arrive in a few decades,' would we just reply, 'Okay, call us when you get here, we'll leave the lights on'?" Or, what the idea is, or would we do something about it to prepare for this potential change in circumstance? So what could humans do now, can humans do now to prepare for possible pitfalls of this technology?
Exactly what we were talking about, thinking hard about these questions. There are a lot of research questions people have done on fire safety, on nuclear safety, on biosafety, and there's correspondingly a lot of difficult research challenges one can do to do it with avoiding any pitfalls with AI. And we wrote this simply to encourage people to do that kind of research, even though it might be far off. I think it's important to remember also that whereas some technologies, right, some things you might worry about, it might be mostly downsides if you think of it whereas with AI, there's also this enormous positive upside. So it's just really, really vast. And if there's something with huge implications, either positive or negative, then even if what some particular research has only a 1% chance of making a difference, that means on average it's going to make a really, really big difference. So it's actually worthwhile. And I don't feel it's too early for people to have a level-headed, calm discussion and doing this research. I'm not at all in favor of, sort of Luddite scaremongering, and journalists have a tendency to, whenever anyone brings this up, to immediately run a front page, especially in British newspapers,
That would be people like
with a picture of the Terminator, or the big red eyes on the front page.
Hal. I usually go for Hal.
Responsible AI researchers out there are starting to think more about what choices are there and how can one, what are the pitfalls, how do we best avoid them.
So yeah, what kind of control strategies might be useful as we develop these kind of technologies?
Don't give them goals to destroy other people.
Play nice.
Help humankind. Yeah, I mean, anyway, I think Asimov wrote down like the beginnings of this stuff.
Yeah, but they usually went wrong in his books.
Good point. Look, I generally, I don't know the answer, but I generally agree with Max. I mean, it's the kind of thing that's worth starting to think about. I'm not particularly all that worried. You know, I think nuclear weapons were just a much bigger deal. So anyway, I'm not particularly that worried, although I think at the same time, asking these philosophical questions and thinking more deeply about them is time well spent.
So what are the key hurdles or technical challenges right now to developing a sort of broadly intelligent AI? Are the deep learning systems we have in place now capable of getting us there?
No, I don't think so. I mean, I think they're a huge fundamental step, you know, in that process. And I think what's beautiful about the evolution of AI is that there are so many incremental steps that we can take advantage of right away. And I think we already see, you know, that for previous AI systems, but also now for the deep learning stuff. And you're going to see a lot of incremental advances. I mean, I was just like using these voice recognition systems, you know, for dictation. I mean, it's, you know, I mean, I don't know if many of you people know, but that was like considered such a hard problem. It's remarkable how good that is now. Just with no training on my voice, it's just remarkable how good that is now. I think one of the reasons why it's getting better, it's a combination of the algorithms themselves, but it's also access to data. And I think that's one of the critical things that is now happening in the evolution of AI, but also something that there has to be more and more of. So especially with the internet and people caring almost not at all about their privacy, they're giving huge amounts of data to the companies that are training over this data and learning how to do things we thought would never be done. I mean, image recognition, voice recognition, speech recognition, and so forth are great examples of that. But I think that idea, that access to data and data in context is one of the things that is critical for the advancement of AI, particularly if you want to kind of get at that interpretive reality, that idea that like, how do humans think about a thing? How do they map their expressions, whether they be images or verbal expressions, onto meaning? That you have to be able to have that data, and you have to have that data in context, and you have to drive the collaboration between the machine and the human so that you can start learning over that. So I think that's critical for the evolution of AI. But a lot of the fundamental building blocks are there, and I'm going to say something that you might find controversial, but I think that in the end, when we understand intelligence a lot more deeply, we're going to look at it and go, oh, that's kind of simple, isn't it? Shit.
Yeah.
So I think that's where we're headed. But anyway.
Yeah. You think we're not that complicated when you get down to it?
It's more about the data. Yeah.
Well, in healthcare, I mean, it's frustrating to see, you know, the paper, you know, that's moved towards electronic health records will hopefully speed all this up a lot. It's really frustrating to see that we're still stymied just by folders on a shelf.
Yeah, the progress is slow, but I think, you know, the sorts of advances that you saw Jonathan talk about. I mean, I think those are the kinds of things that are really going to excite and stimulate people and get them to think about it more and invest more. And look, a big part of getting value out of this is making the investment. Because you're right, in healthcare, there are just a huge amount of barriers. But I think when people start to see what's possible, and when you have the innovators out there and the entrepreneurs out there that are showing them what's possible, wow, that can change things rapidly, and that's just really important to do.
Yeah.
And just to add a little bit to this optimistic note here, some pessimists tell me that it's going to take hundreds of years, you know, before you can get human level. Supersede human level abilities in some of these areas because look, we have no clue how the brain works. It's so complicated. Hey, we even, you know, mapped out every single neuron and see elegance, the little worm, and we don't even understand how that works. So, you know, forget it. I think that's very misguided. And as my wife May there pointed out, you know, you could have made the same argument about flying a little bit over a century ago and say, look, it's so hard to figure out how birds work, you know. And you know, when I was born in 1967, we still couldn't build a mechanical bird. But the Wright brothers didn't care. And even after we figured out how to finally get a mechanical bird, and you know, raise your hand if you saw that TED Talk with a mechanical bird flying around. Yeah? No, well, when I came back from California the other day, guess what? I didn't go in a mechanical bird. So evolution built our brains in the way that was the first way it came up with, but that's not necessarily the simplest way to do something like this. Just like that's not necessarily the simplest way to build airplanes. And I think if we just freak out when we see how poorly we understand the brain, we're completely underestimating our ability to come up with simpler solutions that can also help do great things in medicine. I think these awesome things can happen much sooner.
Yeah, if we just sort of free ourselves of our narrow human anthropomorphic focus.
Yeah.
I'm interested in the rate of change, though, of what both of you guys think, whether this is something that can be predicted, like can you sort of guess when we might be sort of seeing these more intelligent systems, or is it something that's going to be like a breakthrough, there'll be some switch and then it's off to the races?
What do you think?
So, I mean, I think, you know, what do I know? I think that...
More than the rest of us.
You know, only because you're asking me, I'll say something. Look, I mean, I think you're going to continue to see a lot of incremental advances that are really cool. And I think, you know, hopefully, I think you'll see them in healthcare, but I think you'll see them, you know, in our daily lives as well. I think you'll see that happening. And I think a lot of those short-term advances will be very much related to the machine learning work. I think it's going to take a little bit more of time and a little bit more investment to get AI to do more of like, you know, what I think of as like conceptual learning or, you know, meta learning. I think that will happen more slowly because I think what that hinges on is on capturing a much richer context about how humans think about and relay the world to each other. You have to kind of get in the loop with how humans conceptualize the world and communicate with one another. But I do think when that happens, there will be an inflection point because that's when machines will literally be able to read everything around them, digest that, interpret that, analyze that, and communicate that back out. And that's when machines become more of thought, you know, sort of fluent thought partners. And I think that will be very dramatic.
Just to add to that, in addition to, I completely agree with you that that's going to be a real phase transition when that happens. But I think in addition to asking questions about when new things will become possible that were completely impossible before, it's also very interesting to look at democratization of things that can already be done, as Jonathan mentioned. And I view that as one of the core ideals of For Combinator, right? That takes something which is actually possible now, except the machine costs $6 million and is super slow and clunky, whatever, and make something that you can connect to your iPhone and will do it for a very, very reasonable price, where you can start using it in all over the third world and so on. And I think that's a separate question, and I think there are already things now that we can do for $6 million, which would be truly transformative once we democratize them and make them so everybody can do it affordably.
Yeah.
That's one of the reasons I'm so excited about For Combinator.
Yeah, that's something.
It's a big uncertainty that you can eliminate. You know, we know it's possible. We can stop arguing about that. Now let's make it affordable and practical.
It's worth working towards. So I think we have a few more minutes, but let's I guess in our last few minutes try to get to some of the existential questions, perhaps. So if we have these machines that are natural thought partners, as you put it, I think, what is our role in this world and in this ecosystem? What do we do with ourselves? Do we just make pottery?
So, or wine.
Or wine.
Or both.
Novels.
You know. So anyway, I have a very optimistic view of that, for what it's worth. I mean, I think that what's great about being human and having been a lot of other things, you know, being able to, fueling your creativity, right? And having that opportunity to enjoy and experience life and to be creative and to pursue ideas and to influence other people in good ways, to make a difference. I mean, as a sort of inspiring talk by Jonathan, helping your loved ones. I don't know, it sounds a little sappy, but
sounds nice.
But I mean, look, I mean, I'm the type of person who I hate cramming knowledge into my head. I can't stand it. I hate doing all the detailed work. I just have an idea, and I wish there was a machine there to help me execute that idea.
It's called a grad student. It's called Nevada Sanchez.
Yeah, that's true. But anyway, having that. But then you got how many Nevadas are there, right? I mean, so you got to go back to the democratization of the thing, right? Making it cheap, making it affordable, enabling people to be creative, enabling people, anyone to pursue their ideas. So getting quick access to knowledge and being guided in the execution of those ideas. I mean, that's incredibly exhilarating to me. I mean, I feel like that's what you want, right? So I'm just not afraid. I'm just not afraid of that, right? Anyway.
Any thoughts about what our purpose is on this planet once the machines are smart enough?
Well, looking at a more practical question, I think a lot of people worry about what will happen if machines can do more and more of our jobs, and if a larger and larger fraction of the people don't really have jobs, aren't needed to do jobs, and most people automatically assume that's doom and disaster. But if we think a little bit longer about it, it's much more subtle than that, right? Because haven't we all thought sometime when we had a lot of chores we had to do, wouldn't it be nice if I were like the king of some obscure country and I just had a bunch of people who did all these things for me and I could just sit around and do work on my pottery?
Right,
or,
grapes, yeah.
That's the situation we might find us in, right? If machines can actually do the majority of the things for us, there will be an abundance of stuff. It's not like there won't be enough food or enough things. So that means it's not against the laws of physics that they can be distributed so that everybody gets enough. And that leads to a very practical question. If you look in history, there have been other situations like that. Right now in Qatar, for example, most people don't work. They get so much money from oil that they don't need to. There were a lot of royalty in the Middle Ages. And some of them, what did they do? They got turned into opium. The princes turned into opium addicts and lived terrible lives that they felt were very empty. Other people in similar situations managed to find a lot of meaning and do wonderful things with their lives. So this is actually an interesting research question for everybody to think about. How do you want to organize a society if you have all the things provided for you so that people actually do have meaningful lives and don't just all start doing opium?
Well, I think but that's what's really interesting about this question, right? Because again, it gives, as I was saying earlier, it kind of gets you to sit back and say, what does it really mean to be human? And how do we think about our future? Like, look at the alternative. What's the alternative of humankind? Just work and more work, right? I mean, what's the alternative, right? You want machines to help you think, to help you be creative, to help you extend the human value system. You talked about the word consciousness. I'll probably use it in a different way. But to extend our consciousness, right? What are we conscious of? What are we capable of being conscious of, right? How much time, like, Johnson wanted to ask me, was watching conscious, conscious of what, right? So we have a choice of what we want to be conscious of. We need the time to open that story, right? And smart machines may buy us that time, buy us that opportunity. But as Max was saying, it's like it raises a lot of questions because it means we educate people differently. We raise them differently. We get them to think differently. We don't want them to be in that situation, where they literally don't know how to assign value to themselves because they're not working and they become drug addicts or something like that. So, but everything changes, including our self-perception and how we evolve in that self-perception.
Yeah, had two quotes in my mind at this moment. Brian David Johnson, who's Intel's futurist, recently told me that any job that could be done by a machine is a job that's not worth having. So there's that. And then Vinod Khosla, I just saw a talk the other day, the venture capitalist, has been famously said that about 80% of what a doctor does could be done by something like IBM Watson. So someone asked him, well, what does the doctor do? He said, well, they might be kind of useful for compassion. And I was like, that's not a bad answer. Compassion's not a bad thing. But I think that just about takes up our time. So I want to thank you guys so much for being part of this. It's been a great conversation. I really enjoyed it.
Thank you so much.
Thank you so much. Thank you so much.